everyone, I'm Alice. I'm a tech lead at a local startup called McCullagh, and this lightning talk is a story about a GraphQL Lambda that I was supposed to be looking after and how it got quite slow and then how we sped it up again. So the trouble started when somebody read a blog post, which is usually the start of trouble. And so we decided to adopt what's known as the data loader pattern. I think if you're in this talk and you don't know what a Lambda is or you don't know what GraphQL is, this might not be the talk for you, but it is a lightning talk, so you only have 4 minutes and 26 seconds left to deal with this situation. Basically, the data loader pattern encourages you to define each field on your domain models independently. So you give every field the information it needs to resolve itself from your various data sources. And this can be really advantageous if, for example, you work at a small startup with a lot of tech debt and your data sources are stored in all different weird systems all over the place. You don't want every developer having to think about all those systems every time they want to return the project model. So this has gone from one database query returning directly to the front end with some mapping to a bunch of asynchronous promises that hit an in-memory data store. Now, great for developer experience, in my opinion. Not great for end user experience. We found that after we'd implemented this, things slowed down a lot. I had a look at some obvious things that I thought might be a bottleneck. We hadn't implemented the pattern incorrectly insofar as I couldn't see more network requests. It seemed like the same amount. I had a look at the Lambda memory utilization. It seemed fine. I was having a read on the various like NPM libraries we were using. I couldn't see obvious issues where anyone was having the same problem. So I was a little stumped. So I asked my group chat, which is called Touching Computer for Money, where I ask these kinds of questions to my friends. My friend asked, good first question, is your Lambda running on a potato? And I had a look at the specs, and as you can see, the memory allocation was kind of potato-sized. And silly old me, I thought that when you set memory size on an AWS Lambda, that controls the memory size, which it does. But the geniuses down at the AWS factory that name things decided that that memory size property should also control your virtual CPU allocation for the Lambda. So I found that while the memory was not a bottleneck, the compute on the Lambda was an issue. And this boils down to a fundamental, not quite issue, but it deals with how JavaScript handles like asynchronous promises. And at the end of the day, this is very unreadable, but I've got two arrays of functions. One's a million just regular functions. The other is a million asynchronous functions. Even though each of these promises resolves instantly, it's a lot more computationally intense to resolve a million asynchronous promises, even if there's no actual delay within the promise. As I said, this is a lightning talk, so I don't really have time to go into how the JavaScript event loop works, but long story short, the first block of code is always going to be a lot more efficient than the second block of code. So how did I fix this? Did I rewrite all of our APIs in Rust? No, I did not. I just bumped up the Lambda size a little bit. Now, this is obviously not going to scale super well, and there's definitely limitations to this approach of just being like, just crank it up a little more. However, I have some arguments in my favor, and I don't mean to boast, but our startup, unlike a lot of startups, like we have actual customers who, you know, they're paying us money to deliver certain features and support certain use cases, and we're not a big team. We don't have a huge amount of time to do extensive refactors or, really strike out and be bold. Like, oh, we're going to rewrite this whole thing to try and optimize something. And so the short-term win of just bumping that memory and vCPU available to the Lambda was a pretty big win in terms of the customer experience. And the cost was not, I think it was like a few $100s a month more, which, executive call by me was that was a worthwhile investment. So what have we learned? Number one, stop reading blog posts. You'll just make everything worse. Second, it's really important to understand the basic limitations of the language you're working with and the infrastructure that powers your code. 3, performance improvements are a bit of a law of diminishing returns. You might, decide to stop investigating something if there's a quick fix available. And also, when in doubt, ask your group chat for advice. Don't really have time for questions, so come talk to me afterwards if you found this interesting. Thanks very much.